the Open Canary. Configuration. So in order to actually use it, you do have to first configure it, and you have to start the configuration code. So it'll be Open Canary D -- copy config, and that just creates the folder for the configuration file and inputs a default file. On the left here on the top one, you can see that that's a logging that we implemented. So it creates a file in var temp called opencanary.log. And then on the bottom left, we have this used as a web server. So we have FTP, HTTP, and SSH open, and it's masking as a NAS website. So that's how it will look. You can see that's how the website actually looks. And then the log will actually show here. You will see once we do the tail, we're going to demo this in a second, but once we actually see the thing, we can see like the destination that if somebody tries to access something, the destination will be the web server itself. And then we can see the source information, so who's actually trying to access it. So it'll show like the source port, source IP address, show time, and it'll show what type of, obviously, port they're trying to access on the destination. You can also do alerts with Open Canary. The only thing about doing the alerts, it's with something called Open Canary Correlator. You do have to have a website and a domain active in order to enable the alerts. They can be either email or text messages. Being that we don't actually have a domain, we didn't set this up, but that's something that you can actually do if you like to. Any questions about that? Okay. And then we'll do a quick demo. So in order to just start it, you're going to do, so I'm already inside my environment, but I'll do Open Canary D -- start. This is just, well, what the, I was testing this earlier. Let me just restart it. What the heck? Sorry about this. It says it's still, let me just check the website.
Hey, it looks like you might want to kill that PUID.
Yeah, it's already running. This is the website right here. I'm sorry. So what I'm going to do now is I'm just going to tell the logging file so we can look at that. And you can actually see by just opening the website, you can actually see the time. Local time adjusted. So 1608, my VM says 1609, so that's actually me when I just checked it. And we can see that the website was accessed. We can also try to, we set up the Open Canary with a local host for the SSH is 8022. So if I do, and if I look back at this, we can see that the destination port right here was 8022. So it logged that as well. So that's just, somebody say something.
Yeah, you can also see the password. There's right over
Oh,
there.
yeah. You can
Yeah.
see the password they
You can
entered.
also see username as well. So everything is pretty much logged here on it's very similar to Snort, how Snort works, but you can actually kind of get an in-depth uh analysis of all the traffic, and it's also capture Open Canary also captures most of the traffic, if not all of it, as you can see here.
You can also set your own banners. This is just the default one, so we just kept it in there. But that's the Open Canary, and that's our demo for part A of the website. Any questions, or should we move on to part B?
So it's a honeypot, right? So
Correct.
explain how it is a honeypot. How does it fit the definition of a honeypot?
Because
You
yeah,
want to
Jeremy
answer
can
first?
go.
Okay. So a honeypot is supposed to be an enticing target that somebody
Turn
might
up
want to.
your volume a little bit. You're very low. Jeremy?
Let me see here. Yeah, give me a second. Is that better?
Yeah.
Okay, because that's as loud as it'll go. So a honeypot is supposed to be an enticing target for an adversary to want to get into, and so the idea behind that is if you have a target that's enticing and that looks maybe easy to get into, the adversary may attempt to go after that before going after anything else. And so when you set up the honeypot, you'd want to basically let them into it and keep a record of all the traffic or anything that they did there. Open Canary simplifies that process for you by not requiring you to set up set up your own custom web server, set up a database server, set up all of these different things. You can just set up a standard kit of services that would be running, and Open Canary fakes those. Their website for it actually provides, I think it's 4 different configurations that you can copy and just use. One of them is supposed to mimic a Windows server, a Linux web server, a MySQL server, and there's 1 or 2 others. And it'll fake all of these different services so that the user connecting to it sees what they would expect to see if it was a real service, but on the other end, essentially all it is a logging service. And so you get these logs, and if you had if you were exporting this log to a Snort instance, or if you had the Open Canary correlator set up to send alerts when something accessed it, because no valid traffic should ever go to the honeypot, any traffic that goes there is either going to be somebody from the security team or IT team doing some kind of maintenance on it, or it's going to be an adversary. And generally, maintenance is going to be a planned thing. So if you weren't expecting to receive an alert that somebody went there, you'd know that somebody had been in the network and they were trying to do something. So it's just another layer of not necessarily defense, because it doesn't really protect you, but it's another source of information and potential for distracting them. Hey, they're there. What's this IP address? Hey, we can now, as you can see in all these, you'll have the log data will include what the host was if they accessed the the web server. So you'd know, hey, it came from this machine. You could see if it came from outside, if it came from inside, and you could try to track down why that happened. And so that's the point of a honeypot.
All right, great job. So great explanation. So now, okay, so let me understand you. Open Canary then created that website. That website is an Open Canary generated website.
Yes. They have a couple of different skins that you can apply. There's also it looks like you can actually make your own skin, so you could design your own website. Say you wanted to.
It has default ones.
Yeah, it has default ones. So you could design your own that kind of mimicked yours.
Now you guys, maybe I missed it because you guys did go fast. So the SSH part, was that also that you set up that SSH service, but it's a honeypot SSH service? Is that what it was?
Correct.
Yeah,
And
here's the config file for it.
yeah, this is the actual configuration file that we set up, and we can see that there's a lot of different types of services you can use. Like they have, have Git right here, but we have it set to false. Currently, we have FTP enabled, so it'll log for FTP traffic. We have HTTP enabled, and then we also have.
So let me ask this question. Let's say that you're in a network and let's say you grab a Raspberry Pi, for instance, right? You install this Open Canary, and then basically you start all these honeypot services. So really what it does is that Raspberry would have its IP with all these ports open, and they're, as you said, enticing websites or whatever. But really, if somebody is scanning your network, they see that SSH open or that port 80 open, and they either try to scan it or try to do something with it, everything is logged. So this just takes care of that logging, and it's not really like the real SSH. Is that what you're saying?
Yeah, no, it's not an actual SSH port. Every service that it does, it fakes. They even have down in there that TC banner part. That is a more complicated part of Open Canary where you can set up. If you had some like service that they don't cover that you wanted to try to mimic, you can actually set that up to try to mimic some other TCP service that it doesn't by default support.
What if
then you can have it?
Let's say so that was what I said about like the Raspberry. That's true. That's how it would work.
Yeah, you just install it on some Linux machine, and it will whatever ones you enable, it will display that as its port, whatever you have it configured for, and all of the banners it displays.
So it'll grab port 22, port 80, and it'll just assign them to the Canary. What if you wanted to then SSH for real into the machine? You would always go to the Canary, right? So it has to be a type of.
So you'd have to set up. In this case, we have SSH set to port 8022. So if you have the default SSH service running, you would SSH into port 22. Ideally, we'd actually have it the other way around. You'd leave 22 as the Canary port because that's the one you'd want to entice to, and you'd just have some weird obscure port for your other legitimate SSH traffic. And you'd probably want to monitor that as well because it would show up on a scan. So there is that to worry about.
So very good. Good job. And then how do you entice them? You just entice them by having the ports open, basically. That's it. There's
it looks like a web, like we have it configured to look like what a web server might look like. So we have FTP enabled, SSH enabled, and HTTP enabled. And so when you'd scan the machine, you'd see those ports, and the idea being, if they're doing a scan on the network and they find those ports, some kind of server is going to look more enticing than just a generic machine, and so it's already got a leg up on looking enticing. And just the fact that they hit it with a scan, you're going to see that. And then if they choose to access that, we don't have necessarily a good way of guiding them to it other than trying to make it the most enticing target around.
So maybe in the banner of the SSH, you put in something like the secret UFO files, something like that, right? All right, I see what you're saying. All right, perfect, great job. Anything? So guys, do you have any questions for this group?
We also have our part B of the project for the RCM, so we can present that as well. Just opening it up.
All right, yeah, so the same group?
Yes.
All right, so this is project A is actually the risk assessment.
Oh, I'm sorry. I swapped around then.
Yeah, so project A and the same group. Okay, so go ahead.
So for our project, the idea of our business is that we're doing a small scale business, about approximately, I think we said 10 individuals. We're doing we develop websites. It's all remote work, and we have a cloud-based services. We're using cloud as a service, AWS to be specific, and then we actually have our own NAS, and it would be like at the home of one of the individuals, preferably like the CEO or somebody. So that's the business that we're doing. The type of departments that we foresaw we were going to be having would be like IT, engineers, development, HR, just basically, again, this is a very small team. And then the equipment, we will be using cloud as a service. There will be remote workers. So the remote workers would be using their own like laptops to actually do the development of these websites that is our product. For the business objective, we have a couple. Move away from the cloud services, so expanding, move away from the next 5 years, increase sales, grow development to handle multi simultaneous projects, improve customer satisfaction, and increase cash flow. So just basic business things that you want to do. Define our assets. Our assets would be the AWS instances, the remote backup, and then company data. Then for the risk assessment, we these are the things that we saw. So we did some research, and we looked into the risk of having a using cloud services, and we also did some research into the risk of having remote workers. And these were some of the more common things that we found. So insufficient visibility, exposed root account, not changing AIM access keys, poor authentication practices, too many privileges, too broad IP ranges, unrestricted outbound traffic, lack of auditing, unpatched hosts, theft of intellectual property, destruction, loss of employee-owned devices, phishing schemes, weak passwords, unencrypted file sharing, insecure home Wi-Fi, and insecure employee devices. So I don't know if you want me to go and read through all of this, but we took those same objects for the quantifying, and we looked and we would say like, okay, how bad is having insufficient visibility? We were saying cloud resources, so we don't actually know our what the resources we actually own because we're using AWS. But because we're a small business, we gauge this one as insignificant. So I don't know. Did you want us to go through all of these individually, or just give you a brief overview?
Well, if you could talk about, like your overall network and then the risk assessment matrix, the RC.
Yeah. So we still have that. So
talk about the most important. You rank them, right? So then talk about the most important. And
correct. We also gave them each of controls, but that's obviously all over here as well. So let me actually do that. So for the risk control matrix, this is what we did. So like just again talk about insufficient visibility. We actually ranked the impact of that pretty low, but the probability, because we are using AWS, is extremely high. We don't exactly know what those devices are. So control for that would to be actually keeping a log of your instances, so you have more control and you actually understand what you're purchasing or using. Same for, well, not same, but for exposed root accounts. Again, we're using AWS, so initially this is really high because you just set up that information and you usually get a risk account. The probability of somebody actually affecting this, we gave it a low, and we would do this by restricting the AWS root account as soon as we get access to it. AIM access keys, high impact, probability medium or moderate, I believe we called it. So we just add the control of the 90-day key rotation. I don't know. Do you want me to read every single one?
You don't have to read every single
Okay.
one. The most important one.
Yeah. So some other ones, just authentication. We thought that was important. So I would talk about the controls that we kind of implemented for these things. So for the authentication, we said that we need strong password pass policy and multi-factor authentication. We need to set up our bring your own device policy for some of these things. We have a lot of policies is most of the controls we have, like file access policy, employee training for something.
Let me just kind of say it this way. So you're the business owners, right? The three of you, and you put in all your life savings into this, right? Let's just say, for the sake of argument. So the way that you would approach this then is, what do you think? What is the asset that is the most valuable to you? Do you know what I mean? That's really the way
The
that I
company data.
yeah, exactly. So I don't know, right? It's your business. So you guys think about it. Like, what is the thing that we either, if we mess this up, we're going to lose all of our customers and we're not going to, we're going to lose all of our money, right? Or if we lose this tool or, so that's really what I want you to pinpoint is what is the thing of your business that has the largest asset value to you. That's why it's called assets, right? It's what is that asset where you think if you lose that is critical. And then how did you then secure it with controls? The other ones are great, but just, that if you ask me how to present it, I think that would be a good way. Which one do you think?
Okay, so I think we all agree that because we are a small business and we're doing remote work and we're using instances and all that, our biggest actual thing is our actual intellectual property, so what we're using to develop these websites and whatnot. So this is why we actually gave it the highest severity rating. And this is actually affecting all of our different assets. So we were saying that we would definitely need a strong encryption policy, and whenever we are accessing or using these things, it would be best to have some type of VPN service so that we can, secure this information better. Um, and that's kind of how we did it. We looked at it from perspective of what our business was and how it would impact our business directly. Some of that happened because we are all remote working. Phishing, because we have multiple remote workers, that's something that happens, and people are very susceptible to it. And that's something that we would definitely need to address as in training. And again, remote working, insecure home Wi-Fi. That's something that we also, while the impact of it isn't as high, the probability of it is extremely high as well. So those are some things that we thought about. Yash, Jeremy, did you guys want to talk about any of these items?
Yeah, I think especially the insecure home Wi-Fi. Let's say you're working from Starbucks or something, since it is remote, right? So the employee or the end user can pretty much can work from anywhere. You're sitting at Starbucks, but we usually advise, would implement VPN. So before they even have access to any of those resources, we would, have a VPN access to each of the employees for them to actually, connect first before they can access any of the resources. So that's another, control measures that we thought of that was very critical in that sense. Yeah, I think the RCM uh, pretty much clears most, if not the important assets and the controls.
So you guys, so you're concerned, wouldn't you be, so you develop websites for clients, right? And wouldn't you be concerned that somebody hacks your clients?
So that's something that we actually discussed when we were first deciding on the business plan. We're not, so the idea of the company is that we are just strictly into development right now. We're not doing maintenance or continuing with the client afterwards. That's something that we would like to build in, and that's kind of what we talked about, like increasing revenue, because it's kind of like a one-off service. We have these good, sets of templates and whatnot that people use, but we don't actually host the websites. We don't actually like provide updates or things of that nature.
So you
Um,
just sell like people sell CSS templates? Is that what you mean?
I mean, something like that, or we just develop the entire website.
So
We
you
just
develop
give
the
it.
website, and they,
Yeah,
they would host it probably on AWS,
yeah,
but still you are your software assurance part, right? You're still responsible for, that they don't get a SQL injection or something like that, right?
correct.
Okay. All right. So because what I mean is, even though that's part of like you're securing your process, because if that happens, a lot of your customers might ditch you. You know what I mean? So
Yeah.
they'll talk to each other.
Definitely, definitely, yeah. So just good practices of web development in that case that
There you
you may be
go.
referring to, just the SQL injection that
Training,
can happen,
training for that, right? All
right?
that.
Yeah,
Okay.
so that's something that definitely needs to be considered. Even though it's a one-time deal done type of situation, we still, as a web developers, still would need to
Yeah,
take.
yeah, because it's sort of this thing where it's like if
Right.
like when you build a car and you sell a car, you're still you still want
Right.
that engine not to explode.
Yeah, it creates a bad reputation for the
Yeah,
company at
yeah.
the end of the day. So if we look into, increase clients, obviously you don't want SQL injection happening every client that have worked with, and realize it later on that, hey, it probably wouldn't a good idea to patch those type of vulnerabilities.
Okay. All right. Great. All right. Sorry. Keep going.
No, and then we were question 8 was just asking for definitions, so that's for aspects of terminology. And then this is our topology kind of. This is something that we actually kind of had to pull from like just a graphic just because we were thinking about using AWS. So this is just more like the overarching idea of how a network would look. Um, and yeah, unless you had any additional questions.
No, I already asked my questions. Guys, do you have any questions for this group? Nope. No questions. All right, great. Thank you very much. Good job. Excellent job. All right, so I think we have the group of Davina Jackson is next. So go ahead, guys. And again, state the names of your teammates and then get started, please.
Okay, so we have Pedro.
And just maybe turn up your volume a little bit so it's low.
Does that sound better?
Still low, but a bit
How about now?
better, yes.
Okay. So we'll be presenting part A and B.
Who are the members in the group?
I'm about to pull up the
Great. All right. So I give the floor to you guys. Go ahead.
So we have James Michaels, Pedro Trujillo, and me, Davina Jackson. And we're starting with our part A, the risk analysis and assessment, and we chose AT&T for our company.
So the project scope for this company will be to determine the objectives of AT&T and their services, to describe all the assets of AT&T they have, like the computers and data they have, to determine the threats that they have, and determine the controls to combat those threats. And then in order to assess this, we are going to perform a risk assessment by creating a risk and control matrix and diagram a network topography. So basically the main objectives of AT&T is to provide cellular services to consumers, and to provide also something called FirstNet. FirstNet is basically a high-speed network for first responders. So when a natural disaster were to occur, the first people that will have their network up would be these first responders. And then another objective we would have was to maintain the cell towers to ensure all cell coverage that we have throughout the country. So our biggest assets in AT&T would be our physical location. It would be on our corporate store. In that corporate store, we would have physical equipment such as servers, cabling, switches, phone lines, cell towers, the whole 9 yards. Some of the logical assets that we have are facility data, which will describe things in the facility that we have. We will also have employee data, which is pretty important to know some of our employees information that we have, the credentials, who has access to what in the building. And then we will also have customer data, which will have billing information, credit card information, a lot of the information that will be associated with their accounts. Then we'll also have product data and the Opus and an Opus, something called an Opus system that retailers use in order to process customer data.
So when looking at the risks against AT&T, it does seem like a lot of it was both information and infrastructure related. As such, we want to protect against those the most. So to keep infrastructure going, some of the potential risks to that would be a natural disaster, fires, floods, if the local power infrastructure goes down, then to protect against data and allow the data to be available. So using for the first net, protecting against data, to protect against worms, trojans, ransoms, rootkits, anything that could compromise integrity or confidentiality, and then allow data accessibility. So things that would risk that, such as DOSes and DDoS attacks, data theft, if someone can access something they don't through privilege manipulation. And finally, threats against personnel themselves of AT&T, so stealing their information, identity theft, and impersonating AT&T employees were some of the risks that we looked at. So the impacts of these risks could be loss of data, loss of business downtime, having to rebuild infrastructure both physically and potentially network-wise, and then stolen information, unauthorized access, which would invalidate confidentiality, integrity, and availability. They could potentially restrict access to critical business systems such as Opus. It could even spread to other systems and react to theirs. Threats to the personnel is personal information stolen from them, and they could have access to whatever the employee has access to, then whatever malicious person would have that. Then, as I stated previously, the malicious activities such as DOS and DDoSes would limit FirstNet and other company availability that they have and grant unsanctioned access to systems. The way we planned on mitigating these threats was to have, in this case of physical threats for natural disasters, is to ensure that these sites are up to date to construction codes, that in the case of power outage, they have backups that they need to, let's say if they have information that they need to save before power goes out, that they have access to anything that could prevent fires, floodings, and our local safety regulations for information attacks to prevent against unregistered access, use access control lists, encrypted files, ensure that antivirus and malware software are up to date and active, and limiting, if a system does get infected, then you cut that system off as fast as it can so it can't reach out. For personnel threats, training employees to recognize phishing attempts, to know how to respond to them and forward them to proper AT&T like security teams, and then ensure that personnel do go through consistent password changes. So if someone did gather password information, that it would become ineffective by the time they were able to crack it. For malicious activity, routers should be able to recognize and redirect DOS or DDoS attacks to overflow servers so that their availability would still be possible. And then data should be secured behind passwords and access control lists.
So some of our main risks are addressed in our matrix that we created, and some of the matrices I've seen are the natural disasters such as like severe winter storms, thunderstorms, and all that. DDoS attacks, which are performed easily to the AT&T servers. Social engineering. Social engineering allows other people from like different levels of the corporate store to use other people's information and credentials in order to do malicious intents. And one of the big things, as I've experienced working at AT&T, are power outages, because power outages will, if there's a power outage within the corporate store, phone services will continue working. However, new customers will not be able to activate new devices to that network. So as you see here, we have the risk and control matrix. And as I said before, natural disasters. Here, as you can see, have a severe damage rating, and sure, the properties are medium to high. As we all know, like Texas was in Dallas, Texas, there was a winter storm at AT&T, and it did damage the corporate store quite a bit. So in order to combat this, AT&T made backup infrastructures to ensure that the FirstNet responders were able to have their networking working condition. for fires, such as fires as well. We have like smoke alarms and all that. And to control the social engineering aspect of things, as James just said, we train our employees to keep their credentials confidential, because as in my experience, when somebody asks for your information for password and you give it out, it's automatic termination, because that's in the corporate store, that cannot happen at all. And then we continue on with our viruses, malware, and basically for these to control these, we'll just have a set up a firewall, antiviruses, deep freezes, and make sure that we keep an eye on such attacks, and know like where to focus on in certain areas.
So here is a more detailed slide of our controls. We split up into the 4 categories again, and just talking about each control. So physical threats, we have the backups, trainings, the information attacks, we have the ACLs, updates, maintenance, network access control, deep freeze. Personnel threats, cameras, trainings, keys, locks, device hardening, updates, and malicious activity, the antivirus software, spam filtering, monitoring, and firewalls.
So here we have a simple network diagram of the corporate store. So we have the central router, which is the central router that connects to three switches. The switch on the right shows the facility and employee data, which will keep important data for employees, their start date, their end date, termination, reasons why, all of that. Then on the left, we see the customer data. Customer data will have varying information such as billing information, passwords, their who owns the accounts, and then on the bottom switch we have, I can't really see
Product data.
Product data there. Thank you very much. Yep. We have product data, which will show all our products that we have, and all obsolete products, which is very important, because when a product is obsolete, we must notify customers if when a product is obsolete. So like if they try to use it on our network, it will not work, because now that product cannot be sustained in AT&T's network. And then up on the top, we have a firewall that controls everything that goes to the internet. So we can control like what our employers are using, what goes out of the router from the corporate company, and what goes into the router from the corporate company.
And that's the end of our part A.
Excellent, great job. So just one question: what would you say is the asset that you're most concerned about for your company? What would be the asset?
It would have to be customer data.
Customer data.
It has to be customer. Yeah.
It's not, for instance, the network going down and lost revenue.
So like what I would see is like the customer. Sure, like when the servers go down for like our network and whatnot. Sure, like it'll affect the cost, but it costs more if we lose customer data and we lose trust in our customers.
Okay, that's your main concern, is that losing trust. Okay, I understand. Perfect. Guys, do you have any questions for this group on Project A, the risk assessment?
Nope.
No questions? All right. Okay, so it doesn't seem like there's any questions. So now, are you guys presenting Project
Yes.
B as well? Okay, go ahead then.
So our Project B, we are doing defense against DNS attacks. We're starting with a refresher of DNS and DNS attacks, because I needed this when I started the labs. So the DNS is the domain system, the internet's phone book. And what it does is it translates host names to IP addresses and vice versa through DNS resolution. And DNS attacks are the manipulation of the resolution process with an intent to misdirect users to alternative malicious destinations. And we are doing 2 examples of DNS local attacks, the spoofing DNS responses and the DNS cache poisoning. So for our setup attack, we used 3 VMs on the same LAN, and the more basis of our project B is defending against these attacks, so we're not going to go through too much of the attack portion, mainly focusing on defense.
Okay, sorry about that. I gotta share my screen first.
Talk about this first.
Oh, okay, yeah, no problem. So in a spoofing DNS response attack, the attacker essentially attacks a client while the server is unreachable and unresponsive. So first, like the first thing that attacker must need to have the attacker be on the same local area network as the user and the DNS server. Like I said, the DNS server needs to be turned off. And then the user VM issues a DNS request to the DNS server and resolve an IP address of the host name. And after hearing this, the attacker will spoof a fake response to the DNS client, and that is accepted to the user. And then the user will reply with a spoofed response. So here, let me show you that if I can. Screen. Can you see this?
You have to share your screen.
I thought I did. Give me a second.
It's still a.
Oh, yep, there we are. Sorry about that. So right here, I have my 3 VMs, my attacker VM, this is my attacker VM, this is my client VM, and then, and then this is my server VM. So since my server VM is up right now, every time that I decide to ping a website, ping google.com, you see, like I'm pinging this right here. If I ping the bank33.com website right here, I'm gonna get an unknown host of www.bank33, and whenever I do that, it'll just answer automatically. So let me turn this VM off for you guys. And I can't click away out of this, so just be patient. And then now. Perfect. And now, when I perform, still be able to get be able to ping google.com, even though the thing should be, yep. So be able to do that. It might be a little unresponsive a bit, but now when I ping 32.com, I should still be able to get the unknown host. Just give it a second. Yep, still an unknown host. However, now when I perform the attack using a netwox 50, netwox 105 to bank33, this IP address right here, to the client server IP. What? Oh, sorry, I need to perform this first. I use send the incoming packets in here. Then I perform the attack, and I get a successful response attack. And here, as you can see, I'll give it a second. So let's respond. Oh, that's peculiar.
Ping it again.
Yeah, it's just taking a bit. Yeah, it shows a successful attack right here. Oh.
So hold on. Before,
Sorry,
so this is a sniff and spoof. So start the sniffer first, and
Yeah.
then do the ping.
Oh, okay.
So just gonna wait there, and now ping.
Yep, there we go. Thank you very much. I usually perform the ping and then it was when I send out the attack. But yeah, so this is what I get right here. So it sends me a false IP address right here, using 1, 2, 3, and 4. And now let me stop this real quick. So this means that the attack was successful now. So in order to defend, we have set up IP tables in order to defend from such attacks. So one quick second to show that there's no IP table set up now. And you just copy and paste this right here. This right here, this IP table right here will this right here will block all incoming UDP ports from port 53. And now going to from the attack.
Can you show the hit count?
Of course, yeah. Give me 1 quick second so I can display this, and then you can cut right there. As you see right here, there's no response yet from this. Give it 1 quick second. Yep. So there you go. Now we know that the IP defense was successful, since now we have an unknown host even when we perform the attack right here. So now we can go to the second IP table. Clear the first IP table. And then this IP table right here will allow us to specifically block. This will help us to specifically block a certain domain. Right here, input and string, block bank 33. Let's go ahead, perform the attack.
Show the hit count.
Oh, yep. Thank you very much. I always forget about that. And as you can see right here, we have successfully blocked all incoming packets from that domain specifically.
We just now demonstrated the spoofed response defense using IP tables, and now these were the hit counts specifically than when we first tried our IP tables rules, and now we're going to do the DNS cache poisoning attack using IDS alerts.
So in this case, for DNS cache poisoning, it takes kind of a similar vein. However, instead of attacking the user, it attacks the server. It poisons the DNS cache, so it forces the user to go to an incorrect DNS location that could be potentially holding malicious. software responses, whatever potential malicious activity the person could think of. In my case, I will demonstrate it. Give me 1 second. Okay, you should see my VMware workstation screen with 3 virtual machines. In this case, virtual machine 1 is the user, this is the attacker, and this is the server. I use Snort's IDS to create alerts to alert whenever a potential DNS cache poisoning is taking place. In this case, just use google.com. So normally this has all been cleared out, reset, so no attack, quote unquote, is taking place. So if you just do a dig to find all the answer section, well, in this case, the answer section is what changes for this command. I will then move to my attacker machine, still using netwalks 105 to set up the spoof, and we're pointing it towards the host, which is the DNS IP. So we're running this, and then rerunning the dig command shows that this, oh wait, let me turn on. I think I actually started the server. Give me a second. There we go. There. As here, you can see that the IP has changed away from Google's actual IP to the spoofed one and the spoofed authentication. So here in this case, this has been a successful cache poisoning. And then okay, I don't quickly have the cache readout on standby. So now I will show how to actually prevent or alert that a potential cache poisoning has taken place. So here I have my DNS Snort Rules set up. I've added 2. So one is just a general DNS potential cache poisoning. The other one is specifically for Google. I'm going to just count this one out to begin with. Update it. I'm going to flush the cache, restart the server just in case, and I'm going to stop the attack just in case we flush this. Okay, so now starting from the top again. Start Snort on the interface. And then here, recheck this. This redirects to the proper information. So run the attack, run the dig, and then this gets the first alert of potential bad traffic for a potential DNS cache poisoning, gives a priority readout, gives what IP it is and what it's directing towards. So in this case, I'm going to stop the snort, flush the cache, restart the DNS server, stop the attack, do it again just in case. I'm going to also uncomment my second alert, recomment my first one. And then get back to start the attack. So now let's say it was not trying to domain cat or poison google.com's reference. Say oh well, I already used facebook.com. Did that earlier when I was testing. There, now it's going to give a printout, but we won't get any actual alerts. So then when you do though, go through, still gives the bad readout because of the netwalks command. And then, oh, I didn't start it. My bad. Give me 1 second. go through this. Now I get potential bad DNS cache poisoning for google.com through referencing the content for the rule on Snort. So in this case, I showed how a general and a more specific potential DNS cache poisoning can take place on a DNS server.
So then the last part of our part B, we start talking about real life situations if we had a company and we thought of other defenses against DNS attacks, not just the IDS alerts and the IP tables rules that we learned in class. So we'll read our through the list, starting with James first, I believe.
So what I found for other potential things you can do to prevent DNS cache poisoning or other DNS issues is to update your DNS servers themselves. Because from my understanding was modern DNS servers or DNS software has additional security measures such as port randomizations and transaction IDs for information interchange.
And then mine was to filter DNS servers. So change the default port, which is 53, change it to a different port because the attackers are going to attack 53. And I thought of this because whenever I got a new router and I moved out from my parents' house, my mom always told me to change the default password because that is easily accessible in case a home intruder or just password cracking. Pedro?
And mine was use multi-factor authentication because like the more passwords, basically the more passwords you have, like the more things you got to go, attacker has to go through, and it strengthens control of certain users with certain roles in the company.
And that is the end of our part B.
All right, great job, guys. Are there any questions for this group?
Nope.
No questions? All right, great job. Thank you very much. All right, so we have Megan Mahoney, Alex Brown, and Derek Pioro. Are you guys ready to go?
Yes, we are. I guess I'll go ahead and start with the part A.
You guys can start whenever you're ready.
Okay. All right, can everyone see this?
Yeah.
All right.
Yep.
All right, this is the our risk assessment. Our business is DIM minis. Just the first initial of each of our names. It's for the business information. It's located in LaPorte, Indiana. The different departments is factory, shipping, warehouse, and customer service. Our IT requirements is a hosted website to sell the product, a database for the customer information, a server holding the design plans for the minis, and we have an intranet email server. The business objectives is providing high quality miniatures at reasonable prices, providing the best quality customer service, increasing our customer base, company expansion, raising profits, and lowering costs. As for the information services part of it, it's providing and maintaining an easy to navigate website, protecting customer employee personal information, providing secure intercompany communication, and maintaining the company intranet. All right. Our assets include the building themselves, which is the main office building, which is the upper floors of it, the factory and the warehouse, which is the main floor. The physical equipment includes servers, a PBX phone system, wireless access points, routers, switches, cabling, the product itself, and then the equipment for manufacturing. And then there's the data itself, which is customer information, employee information, the mini design plans, and the network infrastructure itself. All right, some of the risks, and of course, is your common, malware, virus, trojans, worms, etc. Social engineering, impersonation, identity theft, phishing. More risks, inside outside threats, which is theft, both physical and of data, cross-site scripting for the website, DDoS attacks, privilege escalation, and then of course physical threats such as fire, snowstorm, power outage, and internet outages. I did a small risk register to try and rank, some of our main assets and the priorities. Our main priority to protect is the database, which holds the customer information. With it being a website, they can store their credit card information. And if that were to get stolen, that would be a major blow to the company. And I did do an RCM, of course. There's a lot of severe potential damages, but most of those, the probability is fairly low. But the main risks determined from the RCM would be spam, phishing, and disgruntled employees. A current employee gets upset or an ex-employee fired. A lot of times they can go inside and just wreak absolute havoc on them. And they're the main risks just because of high probability and the amount of potential damage that could be caused from it. The controls in place. The first one is employee training, because usually a person is a company's weakest link when it comes to security. They click on a bad link or open something they shouldn't, or even leak information. There's network access control protocols, firewalls, locks, man-trap, building maintenance, and etc. And then I do have the floor plans of them as well. And also here is our network diagram. I just kind of threw it together. It's not pretty, but I think it, gets the point across. All right, here, let me go over this a little bit more. Where was I? No, here. Okay. All right, yeah, I guess that's all I have.
So what would you say is the most important asset in your organization, and how do you, what are the controls that you want to put in?
The most important asset was the database with the customer information, and the controls in place to protect that would be network access control, firewall, and intrusion detection system.
Okay. All right, great job. Guys, do you have any questions for this group on the risk assessment? No questions? All right, great job. So are you guys doing project B?
Yeah, that's going to be a two-part thing. I'll do the first BGP part, and then I'll hand it off to Megan.
Okay, all right. So are you guys ready?
Yeah.
Okay, great. Go ahead, please.
All right, so we did the BGP lab. My team is Derek and Alex and Megan. The problems are task 1 is building the containers for autonomous system. Task 2, the internet exchange point. Task 3, transit autonomous system. Task 4, enlarging our internet simulator. For task 1, building the Docker containers, you have to edit the bash RC and create an alias for a Docker PS and Docker SH. If you're not familiar with the Docker, you have to open a terminal. In the folder, you have the Docker compose YML and enter Docker compose build, and it will compose all the various files of your simulation. Then you enter Docker compose up in order to get them all online and running, and down to shut them down, which is needed when editing the files or editing the YML. So here's me getting into the host and pinging the routers and pinging the host. As you can tell, the router is reachable, but the host isn't. This is me also doing the alias for docps. So it's, you don't have to type in the whole thing. And this is just me pinging it and it working and not working. Task 2 to 2.3 is connecting the cable, pairing directly and pairing via route server. Connecting the cable is basically getting into AS150 and AS151 and pinging the host from one to another, and then using traceroute to see how it goes through. As you can tell, it is reachable. Adding the local and neighbor IP address in each other protocol Bgp block allows them to reach each other through pairing directly through IX100. This is start exchanging route information and test whether the two hosts can reach each other. Here are the results. And here are the little additions. You have to edit the files. Pairing via route server, this was a little bit harder. You have to modify the pairing between AS150 and AS151 so that they pair via route server provided by IX100, which you have to add the neighbor IP address as 100 to a corresponding BGP route server and do a trace route to observe it. That's what we got. Task 3 was pairing at multiple internet exchange points, adding internal BGP pairing, adding internal routing, inspecting BGP. On the bottom left is how it's set up. And you have to ping 152's host from 150's host. You run the IP route command and show both the BGP routers. And that'll be the next slide. The top one is one of the BGP routers and the bottom one is the other one. And you can see that it does ping each other. Adding the internal BGP pairing. And explain why iBGP sessions will not prepend their own ASN or next hop will not be altered. And that is because the BGP sessions preserve the next hop attribute learned from EBG pairs. This is why it's important to have an internal route to the next hop. For iBGP, the protocol states that the next hop that eBGP advertises should be carried into iBGP, which is internal BGP and external BGP. Adding internal BGP pairing. This is task 3.3. BGP router in IX100 is not connected to that network. It does not know how to reach the other network because the BGP changes the next hop, but the iBGP doesn't. That makes it unreachable. As you can see, it says it's unreachable. adding the OSP protocol to our bird configuration file, make changes to the bird configuration file, and then explain. After changing the bird files and adding the TOSP table and the OSP protocol, Ethernet 0 is used to connect to your internal network, while Ethernet 1 is used for the outside network, which makes it reachable. Inspecting the BGP, basically observing how BGP protocol works and showing the route, and then disabling it and enabling it, and then seeing how that changes anything or how it makes it unreachable and reachable. And then task 4 was enlarging the internet simulator, which was a lot of work because you had to just basically make all your own files and edit the YML completely with no instructions how to even do it. And you're supposed to get it looking like the bottom left. This is an image of it all up and running. And it wants you to show them all the changes you made. So I just have basically all the files and all the changes I made to the files. Changes to a Docker folder in the IX 101 and 102. More changes. More changes. And more changes. And that's about it. Any questions?
Right. So you're building a network that is more than a local network, right? So like internet. And so some of those are routers, and you're implementing OSPF and BGP protocols, correct? And then you ping through. That's basically what you did, correct?
Yeah, and then they wanted you just to use different like methods of showing how this works and how this doesn't work. And then the last task was basically just making it way bigger on your own and seeing if you could do it.
Yeah. All right. So Megan will continue with this, or is it a separate thing?
It's separate, but
Okay. All right. So this one, well, you showed the slides, so you don't have to demo it. So it worked, right?
All right.
So basically, you built the network. So the advantage of this is that it would be a big network, and then I assume you could, besides pinging, you can do other services. Correct?
Yeah, you could control it way easier.
Attacks and defenses and things like that.
Correct.
All right, great. All right, that sounds good. All right, so Megan, are you ready?
Yes, I am.
Go ahead, please.
Okay, so can everyone hear me? Make sure.
Yes, we can hear you. So it is related to BGP then. So that's what I had asked. So good.
Yes. So what BGP is Border Gateway Protocol. It's basically how all of the ISPs that exist out there on the internet are connected and how they communicate with one another. And so we created a BGP infrastructure for our company, our DAM minis. So this is just a small portion of the infrastructure, but basically we have 3 separate autonomous systems all within our network. One is for payroll, one is for IT, one is for sales. Each of them has their own router, which then connects to all of the computers in that department. And so each of those routers is in charge of a subnet. So payroll is subnet 10.150, sales 151, and IT is 153. So the way that this works is basically all of the computers that are in the sales department can send traffic to and receive traffic from the payroll department, the IT department, all of them, because they're all peered together. And the traffic just goes from one PC into its router through the internet exchange point and into the machine that it's directed towards. So this is just showing how each of the sections, the trace route to show how the hops travel between the two sections. And so in this scenario, basically the IT department workers feel that they're not being compensated fairly. And so they are performing a malicious attack against the, or to figure out what the payroll is for the sales department, because they think that the sales department is being paid more than them unfairly. And so they're going to try to intercept the payroll data that is going from payroll to the sales employees' PCs. So basically what is happening is they are hijacking the BGP protocol. So they're going to sniff for the traffic that is on that subnet. So BGP, it relies on each of the routers advertising what subnets they're responsible for and what prefixes they accept packets for. And so any peer can see what these advertised subnets are. The people that are in the IT department can see the subnet that is for payroll and see the subnet that is for sales. And so since they can see this, they're being trusted with this information, it's easier for them to sniff out specific traffic and spoof the packets from that subnet. So unfortunately, with the simulator, the way that it was, we didn't have the different like Telnet and other TCP protocols accessible through the machines because they were within a simulated network on a VM. But we were able to ping to show how traffic would travel between them. So here I was pinging from a host on AS151, which was the sales router, from the host on AS150, which is a payroll. So this would show how traffic is traveling from a client computer in the payroll department to a client computer in the sales department. And then the user on AS153, so an IT person who wants to know this information, it can then sniff the traffic just using the subnet that is being advertised by the autonomous system. So here we have them sniffing the traffic just with Wireshark, looking for all the traffic that is going from the payroll department to the sales department so that they can capture anything that's being sent. So the way that this would work would be for basically to use a sniff and then spoof. So we put together a code in Python with Scapy, similar to what we did in Lab 1, where we wrote a function that sniffs out packets that are traveling from subnet for payroll to the subnet for sales, and then capture the information from that packet, the destination IP and the source IP specifically, and then spoofing a packet back to it so that it thinks that it got a response even though we intercepted that information. So the reason that that works is that BGP, all of these transfer protocols depend on packets being able to travel through the shortest path available to them. So if an AS is connected to two peers, is it going to choose the one that has an entire subnet available that has to go through all of them, or the peer that has a specific IP address that it's looking for available? It'll go to the one that has the single IP because it's less work for them. They don't have to go through as many steps. And that's the main vulnerability of BGP, is if anybody is advertising a false prefix, advertising a false IP, a false subnet, then it's not secure, and anybody can pull any information that they want from the target. And then this was just showing, I just have the BGP pulled up so that we can see just how the different.
Are you demoing something? Because we're seeing your slides right now.
Oh no, I'm sorry. Shoot. Okay, is that on my VM now?
Yes, we can see your
Okay, sorry about that. So right now I just have my VM set up so that I have a terminal that would be for each of the host machines. So one of them is in the payroll department, one of them is in the sales department, one of them is in the IT department. And so what would happen is if the payroll department were to send information to the sales department, then using that sniff and spoof program that we created, we would be able to capture whatever these packets were. In this case, they would be ping packets, but capture whatever information that we were looking for. And then if the original sender of the packets was looking for the response, then we could spoof the response as if we were the target and sent back to them. And that's about it.
So what's a defense for this, for BGP vulnerabilities?
The defenses would primarily be good filtering. I have that. Shoot. The only option is really to hope that the provider has good filters and it monitors where the prefixes are being announced from and to. So basically, that's just somebody's job, is to make sure that the correct prefixes are being broadcasted from the correct ASs, and then to also implement an IDS in each of the autonomous systems so that they can see if these packets are spoof packets or if they are legitimate.
All right, great. So something like, what did you, so the prefixes, right? You said that was the weakness?
Right. So since each of the routers advertises what prefixes they accept packets for, anybody that's peered with them can see that prefix and claim that prefix as their own and just say, well, actually, this is what I'm doing. So they have to just set up a filtering system to make sure that none of the prefixes overlap.
So maybe an ACL that only says, only allow like this prefix and not other ones?
Right. So yeah, there would be access control lists and firewalls on each of the routers to only allow for certain subnet packets to get through.
Okay.
And an IDS on each of them to prevent the spoofing, because like I said, in this situation, we would be spoofing the packet back to the original sender. And so we would want an IDS in place as well, just to look for those potential attack packets.
Okay, all right. So yeah, so it's like a list of only these are okay. Only
right.
Subnets or okay. So this is a new class of attacks, right? BGP and OSPF. So very good, great job. All right, very interesting talk. Guys, do you have any questions for this group?
No.
No questions? All right, so who would like to go next?
Professor, I think our group is ready.
Okay, go ahead.
Okay.
Put your names up on the board and then start the presentation, please.
Okay. Okay. So our group include me, Belly, and Yuhao 1 and Fei Yuan 1. Okay. We're gonna do the project A first, which is the RCM.
Give me a sec. Let me just get the names.
Okay. Sorry. Yep. Name is right here.
All right, please start.
Okay, we're gonna do our project A first, which is the RCM. Our we are gonna do the RCM for a university. It's gonna be having a 2 campus. It probably located like 5 miles away from each other. For the IT requirement at the school is like maintain the servers and the network. Also the users account management for all the employees and the students. For the department, it will have human resource, financial aid department, payrolls, and for all kind of different academic departments, like a math department, CS department, all those. Okay, the business objective is like help the student getting success on their colleges. Okay, for the assets, we have the physical locations, like the building themselves. Also have the physical equipment like router, switch, wireless access point, cabling, firewalls, all those. For the logic assets, like faculty's data, students' data, and also availabilities of the network. And also the infrastructure secrets, like IP address mapping, map, security controls, all those configurations. The risk we have is like five major of them, like malware and the malicious activities, social engineering, configuration errors, and physical threats, like virus, worm, for the malicious activities like DOS attack, um, privilege, I'm sorry, escalations. Okay, guys can read all these. And we have our table right here. So for the schools, the main point is keep the students and also the faculty members safety. That's the highest point. And also for the network security and making sure the network and all the physical device equipment that working properly in the campus. That's the highest point risk. So like for phishing spams, we didn't mark them like very high level damage, but for virus, like network attacks, network worms, privilege escalations, and fire, natural disaster. All those are like the security level are very high. Like, and also as you see, we have the those threats related to asset, and also how to control them have list in the table. Since that table is too long, I'm not gonna go over them. So just give you a general detail like what's important and what is not that important. Okay, gonna turn to another. So for our campus, we're gonna use the Office 365 AD for our faculty members. Those are like for the Outlook mails for the employees, and also for all Office 365 ADs, they have a 2 mode. One of them is the cloud only. The other one is gonna be the hybrid. We talk we discussed about this in our teams. We decide the schools, it's better to use the hybrid mode because we also need the Office 365 AD to control all the physical equipments, like all the computers that are located in the schools. And we decide to using local DNS servers because the local DNS servers is very reliable. For the students, we decide to use the Google account, like Google Cloud, G Suite and Google Cloud for the students. So pretty much all the students are using the Gmails, but also we do have the Google account created for the faculty members also. So in order to make that happen easily, so we decide to use the Google Cloud directory sync. It's a thing that Google designed that are able to communicate with Google Cloud with the Office Active Directory. And also, since the COVID start, we all need to do the online work from home. So we decide we need the VPN for the schools for all the faculty members. We found this application called Perimeter 81. It's a VPN software. The good thing about it is it can monitor the network activities. So every user that are using this VPN, the IT team can actually monitor what they're doing and what package being transferred through the VPNs. And also we can, this software is also very easily to manage the team members' access. So we can decide whoever will get the access and whoever get the priority access. And also another good thing about this software is they are very easy to use. They have easy to use client applications. So that means if we are giving the access to the users, no matter where they at and no matter what kind of device they're using, they can use that VPN. So we can secure their network also. So it's very good application to have to protect users' informations and users' network. And also we have the dual security, two-factor authorizations for, authentications for the students. So it's just like it's the same thing that we're using for the Purdue Northwest. It will highly secure the students' accounts. Also, we will purchase the Cisco's Firepower 9300. That's a firewall mode from Cisco. Like I have a map right here, a simple map that designed for the two campuses. Well, we have a main router that connecting to the network, and as soon as it hit to our internal network, it will go, like all the traffic will go through. Coming to our internal network have to go through that firewall right here, which is this one, the Cisco Firepower. It can monitor all the package that are going through that firewall, and it have the feature that detects and block network intrusions, and that firewall is pretty good against to the DOS attack. That's pretty much all the equipment and the solution that we decide that we're gonna use for the university. This is a quick, simple map. We didn't do a lot on the map. Just that service is gonna related right here, which is the DNS servers. Also, we have the DHCP servers on these servers too. That firewall is gonna be the firewall that I just mentioned, the Cisco Firepower. So, and two campus will have a core switch, which is a layer 3 switches. These two layer switches will do all the VLANs like separate the VLANs, so we can separate our internal networks. That switch and access points right here, it just, for example, we are going to have multiple access points and switches at each campus to support our network. And that's pretty much about our project A, RCM. All right, do you guys have any questions?
Nice job, nice job. Guys, do you have any questions for this group? All right, I'm not hearing any questions. So are you guys ready for your project B?
Yes, we are.
All right, go ahead.
Okay, all right, for our project B, we decided to do the ICMP redirect attack. It's related to our project A, which is to our university. So what is the ICMP? The ICMP is pretty much the it's like a attack will send out a message, like a package to the user. It will redirect their routing table. Okay, just like for example, since user A want to send a package to the user B, it will go through the router C. Okay, if you are sending the ICMP redirected to the user A, it will actually change the routing table on the user's device. So it will change the route. So it will go to, so the package from user A to user C will go to the routers D instead of going through the router C. Or even though the attacker can set up that packet, that user's package is sent out to another point, have to go through the attacker's device first before it's sent out. So it's very high risk for a university that we for the user's information, because all the packages will go through another point that we don't know where it will where it will went. Okay, so how to prevent the ICMP redirects? We been do the research online. It's very easy, but a lot of IT members will forget to do that. It's disable that feature. Okay, the two picture right here, it actually happens at router side, so it will block that features. So all the ICMP redirects message will not be sent out. And we have our demos right here. We'll have our demos right here. Yeah, also that that can be denied at the switch or router side too. So it's a simple create access list will actually deny that package going through the switch or the routers. For the demos, we create a simple networks. It's gonna demo at the VMs. We have a servers which was the IP address 192.168.112.128, and the user that 74.128, and the attacker with 74.130. Right here, that picture shows that the servers, the users are able to ping to the servers with no problem. And we're gonna spoof ICMP redirect package to the user. That's the code that, that's the code we're using to spoof the package. Like we're using the Fireshock to detect the package it being sending through. And now from the users, we ping the test the servers again. You can see it actually it will go to the attacker's computer first, and then goes to the servers. So whatever you send, whatever information you send into the servers will go through the attacker. So that's very high risk. So simply we did not, we assuming that VM machine right here, that is the router. We disable that feature by change the number to 1. So we'll disable it. So now we're paying to this, we're paying the servers from the user. You can see the ping back to the normal route. Okay, and we have the VM set up. He can take over to do a simple demos right here.
Yeah, yes, I'm here, and I will share my screen. Okay. Yes. Okay, can you hear the screen now? Yes. As you can see, we have do the 4 VM down, one attacker, the 74, 130, and router double interface, one for 74 subnet, the second for the 112 subnet, and with VLAN. I'm sorry. The client, this client just and another client. Yes, there is the victim, just the school user, and its IP address is 74 128, and we can easily find some information through the IP table. The 100 this PC to this client IP address is 112 is through the 74 129. This is the gateway, and this address is the interface, one of the interface in this router. And for now, if I want to pin this client, it can be success. And in this is a normal way. And for now, the attacker want to trick the victim to think that this attacker can be a better router to go to the destination, just the client one. So he just can spoof a package and in turn and attach a redirect ICMP redirect package and send it to this victim, and the victim will be treated. And let's send this package now. For now, let's send out. Then let's pin again. Okay, you can see there. This package from at originally this package just sent out from this VM and access the router finally to the client one. For now, it's sent to the 130 at first. This is just the attacker at first, then attacker sent to the router, then the router sent to the client. This is what the ICMP redirect attack did. But if I want to prevent this attack, it's very easy too, and we just to block it to this countermeasure to allow this victim to doesn't accept any redirect ICMP package, and through this way, the attack does not work. Okay, this is my sharing. Any question?
Yes, just a couple of questions. So does it update the routing table of the client that initializes the ping?
No, it's not updating the routing table. It updates the routing. It cannot update the routing table.
It updates the what, sorry?
Oh, what again?
Yeah, it is the routing table. So the ICMP redirector is, depends what protocol the switch and router are using. So it will find a different path.
So my question is, when you did the attack, right? Do you attack the router or the client?
We're pretty much attack the client, not the router.
Okay, the client. So you're changing the routing table of the client
Right.
then to not use the gateway that it had, but use the attacker's IP as the gateway.
Right.
Okay. All right. So what was the attack again? What did you use for that?
Attack just.
Oh, you use a Python
Yes.
script. Okay.
Yeah.
All right. All right. All right. So that was the question I had. So you are actually modifying the routing. It's like an ARP kind of attack,
Yes.
right? But you attack the routing table, right?
Yes.
And then the defense is basically to say that the routing table should not allow certain kinds of updates, or that machine should not allow certain kinds of updates to its routing table.
Yes.
Right.
All right, sounds good, I think. Guys, do you have any questions for this group? No questions. All right, great job. Thank you very much. Perfect. All right, so we are out of time for today. So that means the rest of the presentations will have to take place on Thursday. Okay. Are there any questions before I'm going to stop the